Hello students, I am Puneet Kumar Goyal, Assistant Professor in IT Department, Ajay Kumar Garg Engineering College. Today we will cover the topic of single linked list, and in the single linked list we will cover the cases of traversing and insertion operation in a single linked list. Now first of all we will understand the traversing concept. Now what do you understand by the traversing? Traversing means visiting each node exactly once and read the information in the node. So that first of all there is a linked list. In the linked list we are providing the addresses of each node, and the start pointer contain the address of the first node. Here each node has two parts, that is the information field that contain the information, and that is the address field that contain the address of the next node. And the last node contain null in the address field, because after the last node there is no node present in the list. Now we will start the traversing. So always remember, whenever we start the traversing, first of all we will start from the first node. So we can start from the start pointer. Firstly, start pointer will first point to the first node, then start pointer will point to the second node, then third node, and so on, and the last start will contain the null. So if we traverse using the start pointer, using the original start pointer, in that case at the end of the traversing start will contain the null, and if we want to again traversing the list, we cannot traverse the list because original start pointer contain the null. So for that reason we will take a temporary pointer, PTR, that will contain the address of the first node, yani that will contain the address of inside the start pointer. Now first of all, in traversing we will check whether list is empty or not. So if list is empty, we cannot display any information. So that is the case if start contains the null, that means list is empty. In that case, go to step last and end of if, yani that means traversing operation will end. Now move to the next slide. Here we will start the traversing. Here we have taken the temporary pointer PTR. Now PTR contain the address of the first node. We have initialized the PTR with the start pointer. Now PTR is pointing to the first node. So here PTR is pointing to the first node. So now we will PTR contain 100. Now we will display the information inside the first node. Again PTR will be updated, and now PTR will contain PTR next, that means 100 next. It will contain 200. Now PTR will point to the second node, and we will display the information inside the second node. Now we will again update the PTR pointer. PTR will contain the 300. Now we will display the information inside the third node. Now again we will update the PTR. Now PTR will contain the PTR next, 300 next means null. That means what will be the terminating condition for updating PTR? Update the PTR until we get the null pointer in the temporary pointer field. So here we have initialized PTR with the first node address. Now display the info field, PTR arrow info. Info is the information field. Now update the PTR. At each iteration PTR will be updated, so it will contain the address of the next node. That means PTR equals to PTR arrow next. Now both of these two steps will be repeated while PTR not equals to null. As soon as PTR contains the null, that means your list has been traversed and you have to stop the condition. So this is the traversing case. In traversing we are reading the information inside the node. So traversing, by using the traversing we can count the number of node in the linked list, count the total number of even values in the linked list, total number of odd values in the linked list, sum of all values present in the linked list, In every case, we have to use the traverse function. So this is the traversing. Now, here we will write the pseudocode. Nowadays, most of the companies ask about the pseudocode, write the function in the pseudocode. So we will start the traversing in the pseudocode. Algorithm. Now name the function, that will be the traverse. We will use only the start pointer. Now, at the beginning of the pseudocode, you have to write begin then colon. Now, here we are initialize a temporary pointer ptr with the address of the start pointer. Then we are displaying the information. We will write then ptr arrow info. Again, we will update the ptr. ptr equals to here we have to remember that I have to write while ptr not equals to null and write do. This is the syntax of the pseudocode. While do, for looping we write the do. With the for loop we will write the do, for then steps then do. In that case we have write while ptr not equals to null condition, then we have write ptr arrow info. Always remember, we will not use the brackets in for displaying the boundary of the loop and the if condition. If you follow any statement inside the while, provide some indentation for the right, then also for the ptr. Here we have write these both lines inside the while, not parallelly the while, inside the while. So this is the conditioning for writing a statement inside any loop, inside any conditional statement. Okay. Now both statement has been finished. While ptr not equals to null, write ptr arrow info. You have to display the info and ptr is ptr arrow next. Now write end. So this is the pseudocode. In that pseudocode, we have not covering the case of list is empty. If you want to covering the case of list is empty, then you can write if start equals to null, write list is empty, else ptr equals to start, then while. So this is the case of traversing in the single linked list. Now we will cover the different cases of insertion. Insert a node as a first node, insert a node as a last node, and insert a node at a given position. So first of all, we will consider the case insert a node as a first node. That means we have to insert a node at the beginning of the list. Now, what we have to do? Here we have taken a diagram. We will understand the working by using the diagram. First node contains the address 100. So start will contain 100. Second node address is 200 and third node address is 300 and last node contains the null. Now we have to insert information for t at the beginning of the single linked list. So what we have to do? We have to allocate a memory. We have to allocate memory for that node and assign the address of that node in the pointer. So here ptr will contain the address of the new node. which have been allocated using function malloc and calloc in the C programming. Here we have shown it using the diagram. Now we have to insert that node as a first node. So first we have to insert information field. So we will write ptr arrow info. Now info will contain the item. Here item contain the value 40. Okay. Now mark where we have to change the address field in the node and in the linked list. So this node will be added as a first node. So this address field of first node, address field of newly allocated node will be changed. Now currently this node is the first node, but whenever we insert the new node as a first node, this node will become the second node. This node will become the second node. So address in the start pointer will also change, because now start will point to the newly inserted node. So we have to change start pointer and we have to change address field of new node. So now here address field of new node will point to the node which is currently first node. So that will contain the address 100. So ptr arrow next will contain 100. And where is 100 stored? 100 is stored in the start. Okay. Now we have provided the link of the newly allocated node to the currently first node. Now we have to change start pointer. Start pointer will point to that node. So start will contain which address? Address of the new node 500. And where is this 500 stored? Inside the ptr pointer. So we have to write ptr arrow info equals to item, ptr arrow next equals to start, and start equals to ptr. So if we write in the stepwise procedure, we will also write the pseudocode, but if we want to understand the step by step procedure, then what we have to do? We have to use a start pointer, okay, and information field, address field, ptr and item. Now first check memory is available or not. We have to allocate memory for the newly inserted node. So we will get that memory from the free memory. So we have to check whether memory is available or not. If memory is available, then allocate a new node from the available memory. Then we have to allocate a new node memory for the new node. Now and assign the address into the pointer ptr, which we have done in the previous slide. Okay, ptr will contain the address of the new node. Now information field of ptr, newly inserted node, information field of newly inserted node will contain the item which we want to insert. Now what we have to change? Ptr arrow next equals to start, and start equals to ptr. That we have done in the previous slide. Ptr arrow next is equal to start, and start equals to ptr. So here we have covered the case of insert a node as a first node in the single linked list. Whether list is empty or not, in both cases that code will work. Okay. Now we will understand the pseudocode of insert a node as a first node. Always write function name as camel case. Start and the item. Now begin keyword. As I have already told, whether list is empty or not, in both cases we have to write the same code. Now first we will allocate the memory for the new node, and in the pseudocode we will write a function get node. Get node will work in the pseudocode as same as the malloc or calloc work in the programming. So here get node will allocate the memory and assign the address of that memory to the PTR field. Now memory has been allocated. Now access the information field. PTR arrow info equals to item value. And what we have to change? PTR arrow next equals to start. Now PTR will point to the currently first node, and now start will point to the new node. Start equals to PTR. And so this is the pseudocode for inserting new node as a first node. Now we will cover the case insert a node as a last node in the single linked list. So insert a node as a last node. Here both cases will be different. When the list is empty, then insert a node as a last node will work as a insert a node as a first node because list is empty. And when the list is not empty, then we have to write the different code to insert a node as a last node. So first we will cover the first case of inserting a node as a last node when the list is empty. Okay. Now here start contain the null. We have allocated memory for the new node that will contain the information. PTR will contain the address of the newly allocated node. Now where we have to change? Because we are inserting a node as a last node. So by default you have to write PTR arrow next equals to null, because last node address field of the last node contain null. Now PTR arrow info equals to item. Now where we have to change? We have to change start also. Now start will not contain the null, it will contain the address of the last node or as a first node. So this is the case when the list is empty. Now when list is not empty, that will also cover, and we have to write a different code for this case. Again repeat the same procedure, allocate a new node from the available free memory, okay, and write the PTR arrow next equals to null, because it is the last node. PTR arrow info equals to item. Now we have to insert this node as a last node. So list is not empty, so we have to get the address of the currently last node, because after that node we will insert a new node as a last node. So we will take a temporary pointer, temp as I have already told, whenever you are traversing, always use a temporary pointer in place of start pointer. Now temp will contain the address of the first node. So temp will be initialized with the start. Now we have to update temp. Firstly, temp contain 100. So we have to write temp equals to start. Now temp will contain the 200. That means we have to update the temp by temp of next. This statement temp equals to temp arrow next will be repeated till temp contain the address of the last node. Now temp contain the 100, temp contain the 200. As soon as temp contain the address of last node, that means 300, we have to stop updating the temp pointer. So where we have to stop? While we have to get the address of the last node in the temp pointer. And what is the property of the last node? Address field of the last node contain the null. So we have to repeat this step till temp arrow next not equals to null. So please remember this difference. Whenever we want to access the information inside a node, we also have to traverse, but in that case, we have to traverse till temp not equals to null, till temp not equals to null, because we have to access the information inside the last node also. But whenever we want to get the address of the last node, in that case, we have to traverse till temp next not equals to null. So after this while loop, temp contains the address of the last node. So temp will point here. Now where we have to change? We have to change the address field of the currently last node. Now it will contain the address of the newly inserted node as a last node. So after the while loop, temp arrow next. After the while loop, temp arrow next will contain 400, address of the newly inserted node as a last node. So where is this 400 is stored? Inside the PTR pointer. Now temp arrow next equals to PTR. Okay. So what we have to do? We have to first insert the null inside the address field of the last node, newly inserted last node. Then we have to insert the item information in the information field of the last node, currently newly last node. Then we have to traverse the list. So we have taken a temporary pointer. Now, if we want to understand it, again, first check free memory is available or not. Allocate new node from the available memory and assign the address into the pointer PTR. Now, PTR arrow next equals to, here we have to write null. As in the previous slide, we can see that PTR arrow next equals to null. Now, when list is empty, insert a new node as a first node. PTR arrow next equals to start. You can also write it, but this statement here is not necessary. You can directly write start equals to PTR and also write PTR arrow info equals to item. Now this is the case when the list is empty. That means start contain the null. When the list is empty, if start equals to null. Okay, if start equals to null, then you have to simply use start equals to PTR. No need of this code because it is repeating. Now, when list is not empty, we have to traverse. In that case, we have taken a temporary pointer. that temporary pointer will contain the address of the first node. That means start. Now we have to update it, temp equals to temp arrow. Here we have to write next, temp arrow next. Now while temp arrow next not equals to null, we have to repeat this step, temp equals to temp arrow next. And after this while loop, we have to update temp arrow next equals to ptr. So node will be inserted as a last node. Now we have to again write a pseudocode for it. Insert last, start and item. Again write begin keyword. Now first of all we have to allocate a memory for a new node. So we will write p equals to get node. So here get node will allocate the memory for that node and assign the address of that node into the p pointer. Now information field of the p pointer means newly allocated node will contain the item. Also this node is inserted as a last node. So write p arrow next equals to null. So both are repeating statement. You can write it inside the if else case, you can repeat it, or if you don't want to repeat it, write it once at the top, p arrow equals to item and p arrow next equals to null. Now covering the case when list is empty. So we will write if start equals to null. With the if condition we have to write then keyword in the pseudocode. So if start equals to null, simply we have to write ptr arrow next equals to start, that we have covered in that section. When list is empty, start will contain the null. So if we write ptr p arrow next equals to p arrow next equals to start, that line will be replaced by this line, p arrow next equals to null. Now we have to write a single statement only. Now start will point to that node, last node will inserted as a first node. So here start will point to the newly inserted node. Start will contain p. Again covering the case when the list is not empty. In that case we have already understand that we have to traverse the list. So while using the traversing, we have to initialize a temporary pointer with the address of the first node. Okay. Now we have to update a temporary pointer till temp next not equals to null. So we have to write while inside the else, while temp arrow next not equals to null, write do. So what we have to do? Update the temp pointer. Temp equals to temp arrow next. Now after this loop, temp will contain the address of the last node. So here temp equals to temp arrow next. After this while loop and inside the else, we have to update the address of the last node, currently last node. which is pointing by the temp. Now, temp arrow next will contain P. So, here your algorithm will end. Now, clear? We have covering the case of inserter node as a first node, inserter node as a last node. In the next lecture, we will cover inserter node at a given position, cases of deletion and searching. Thank you, students.